Hi, welcome to the Pole Shift News, the home of the Mavstar Observatory. Guys, we've got some great news coming up. We've had a data packet coming from China last night, nearly a complete month's worth. There's over 2,000 separate readings on that, and we've also squeezed in the resolution a little bit there so we can get a closer look at what's going on over the month. This is what I said I was going to do once we started getting, steady data streaming in from South California, Kentucky, Perth, the Gold Coast, and China, and soon to be India. Guys, we've got these magnetometers in some great locations, but before we get into that, let's say a great big thank you to those few people on Patreon that are supporting us, and those that support us on on PayPal. Guys, without you we could not be doing this. Now, there's a bit of confusion with a few people, and they're a very small amount of people that are subscribed to our channel that seem to think that asking for support for the observatory and what we do is considered begging. Can you believe that? I think for a lot of you, you understand the word begging and what that means, right? And it is nothing to do with what we do on this channel. We ask for support, and the difference is we actually give you back data. And for all those people that have pledged a bit of support on this channel are going to get something really special a bit later on in this year when we get a couple of other projects out the way. I did say once we've got these magnetometers in all the locations, we start getting regular data come back, we would finish off the cloud chamber, and then we would begin the laser project. And those people that have supported the channel over the period of time that we've been going are going to be able to send me something that they want transmitted out into space via laser. And you know what sort of laser we're using? We're using a CO2 laser, so it's a very, very powerful laser. And like I said before, this was going to go past Voyager 1 and Voyager 2, which NASA spent millions and millions of pounds on, putting a record player on there, and similar to what we're going to be doing, transmitting a message out into space. Well, they sent spacecrafts at the cost of millions of pounds to do that, but our messages are going to go past them spacecrafts that was put up in the 80s much quicker. So it's not a matter of begging, guys, it's asking for just simple support. And why shouldn't we anyhow? First of all, we're a global observatory now, and we collect data on one of the most important anomalies that's taking place in humanity. Let that sink in for a little bit, right? We've got 24,000 nearly subscribers on this channel, and there's just a small pocket of people that are helping support what we do. We're covering the most important anomaly that mankind has ever seen, and there's no question about it. Magnetic reversals are rare events, and they incur a lot of significant impacts on our climate, as we point out regularly. But we don't just cover things to do with the magnetic pole reversal, guys, on this channel. We cover a lot of other things, so it's well worth supporting this. And let's face it, there's no control by any mainstream organisation or larger organisation. This is solely supported by public around the world. And so, kudos to you few that do support it. And for those that consider it begging, well, you're completely wrong, because there's no such thing taking place. Beggars don't give anything back, for a start. And I know that a lot of people don't seem to understand that just because we're on YouTube as well as on the internet, but they think that because we're on YouTube that it should be free. There are costs involved. If you can imagine, we've built a complete website, and we maintain that website. We also maintain the equipment now that's going around the world. I mean, this magnetometer has been sent back, the one that's in the Gold Coast, for a repair, and then it's going back out there. Guys, these things are not free for me, but if there was, I wouldn't ask at all for anyone's help. But at the moment there is no alternative. If we're going to keep the data coming in on this most important anomaly that's taking place, then we need a little bit of support from you guys out there. And I hope that you appreciate the fact that we're not asking organisations for their support, because I'm sure before long they're going to say to me, Gene, we don't want you talking about certain things, and Gene, we don't want you putting that data out because it could frighten people. Well, we take it upon ourselves here at the Mavstar Observatory, first of all, to think that you are well capable of the data that we share with you, and if that is shocking data, we expect you to be adult enough to cope with the level of that data, even if it is not perhaps the rainbow gold coated information that doesn't alarm you, because at the end of the day, guys, as a result of the magnetic pole reversals on this planet, people already have lost their lives. As a result of the climate changing, people have lost their lives. And I want to say this is not about entertainment. If you're here on this channel for entertainment, then you're not going to get no entertainment. I'm not here to entertain anybody. I'm here just to provide the facts on one of the most important anomalies taking place in mankind's history right now. There has been many reversals, but none of them have been recorded in the level at which we're trying to do here at the Mavstar Observatory. So we take it very serious. I invest a lot of my time trying to inform people of some of the circumstances that are occurring as a direct result to the magnetic pole reversal. And you might have caught me over on Open Amaranch doing the podcast with Diamond. We share the data with him as well. And it's all taken serious. What we're trying to tell people is it's time to prepare for this event, because it is at some point going to affect all of us on this planet, if not already. I'm not just talking about the cost of food going up because of the arable lands going offline. I'm talking about everything across the range could be at risk. And we have even heard it from some of the mainstream organisations. The director of NASA has even come out and told people to prepare. And what we're trying to do is tell people to prepare. It's like, and I'm not going to go into the Bible too much, but it's like the story in the Bible, about putting up some oil for your lamp so that when the time comes, you have got light. And, if you know that story in the Bible, you know that a lot of people used up their oil before it was needed. And when the time came, they was asking other people for oil for their lamp, and, they said, I'm sorry. You had the same information as what we had at the time. You refused to stock your own oil, and now you've got none. You've used up your stocks. And you know what, guys, I don't want any one of you guys that regularly tune in to my channel and find yourselves at some point in the future with no oil for your lamp. And what I mean by that is just a metaphor, really. Is guys, it doesn't cost much to put up a little provisions for you and your loved ones. And at the end of the day, we are running more than one risk right now. There is so many anomalies overdue, and there is so many things that are taking place as a direct result of the poles reversing on this planet, that it is time that people started to prepare for that rainy day. When you know what, guys, I've said it before, it's the cheapest family insurance policy that you'll make once, and it'll be the one that probably saves your lives and your loved ones' lives. So without any further ado, let's get on and have a look at some of that data that came in from China. And like I say, guys, we've got Ricky hopefully at the end of this week will give us some communication just to let us know that magnetometer has arrived safely. With regards to the other magnetometers, we're going to be having more data come in hopefully throughout this week from possibly JD or Brad over in the United States, and also we've got Jeff in Perth. So there's plenty of data to come in, and then around about the 17th, another 12 or so days, we'll be looking at trimag data and magnetosphere data. So we're collecting quite a lot of data, as well as all the other things on the website that get updated regularly, like space weather, Schumann resonance, earthquakes, volcanic activity, sea ice extent. We're covering pretty much everything we possibly can, and I do, like I say, invest a lot of my time into this, and it is a bit disheartening, when people just come off the cuff and say, Gene, you're begging. It's like heartbreaking, So guys, let's have a look at the data. So guys, as you can see, we're looking at the data from the 9th of the 6th 2019 to the 4th of the 7th 2019. Nearly a completed month's worth of data, over 2,200 250 separate individual data collected points. And you can see that just in the middle of the last 20 odd days, we can see that it peaked, and there's been a total shift of just under 2 microteslas. So what we've said we was going to do is zoom in, and that's what we've actually did on the data. If you compare that with the last test data that was sent from Hong Kong, you can see that the line pretty much looked flat across the graph or the chart. But we've zoomed in on the resolution. I've set it at 16.5 to 20 so that we can see a lot more detail as the magnetometer collects higher and low readings. But you can see generally it goes up a little bit and just peaks over the 19.5 and then starts to come back down. Interestingly, but we can't make any assumptions yet until we start seeing regular data. And what we want to do is see regular data where the left hand column doesn't change so much, and this is not going to be the case. This is going to be the case from now on, because these magnetometers have been screwed and fixed to their position so that they do not move. And we've got no major massive spikes in this data, so that we know that the data isn't being interrupted by random uncertainties or random anomalies. So it's a great collection of data, and over the coming months we're going to have some more comparisons like this to start saying then, okay, we can see there's been over 3 months a gradual shift. Now, where our magnetometers are, if we can just get that up on the chart so we can see where our magnetometers are, and I want to just explain why we've put them where we have. So in this case we're looking at M4 China, and the reason why we've selected that region is not because it's in the highest intensity of the Siberian pole, which is this region here that we can see in between M3 and M4. It's because it's on the cusp of that highest intensity. Now what we're expecting is more of what we've seen over a period of time of about 5-6 years, is that high intense region, the Siberian pole, what we class it as, moving towards the magnetometers. Now what we should see in theory is the trend that we've been looking at over the last 5 years, which is an increase in the magnetic intensity. And M4, the magnetometer, is going to pick that up, and also M3 when that arrives with Ricky at some point in India this week. Again, over in the southern hemisphere where we've got M5 and M6, we can see that the highest intensity region of the Canadian pole, the Australian pole is what we call it, is moving up towards our magnetometers. Again, we should see an increase, but this is going to be a different case for M1 and M2, which is in Southern California and Kentucky, because the high intensity region is leaving the magnetometers. So we should see a decrease in the overall field strength, or the background field strength of the magnetic poles there. Guys, we've been detecting over here in the UK with the TriMag system some pretty abnormal behaviour for the first time in 2 years of studying the TriMag data. We're seeing the magnetic pole migrate at sporadic times during the last 2 months of nearly 250 miles, and we're starting to get a lot of activity. So now more than ever is a time to be focusing on this. And there is another area that we're really not concentrating much on, and I think that it's worth an effort to try and get something done where we can put magnetometers out in M8 and M7, because that's the lowest intense magnetic region on our planet. And it is when this when we get close to the pole reversal that this area will start to increase. As it is, we know it's already increasing, but it'd be great if we could just put magnetometers perhaps on that southern continent of Africa, or maybe South America, or maybe the Falklands. It would be great if we could get magnetometers out there just to find out how much it's decreasing. So there you are, guys. We're going to probably have some more data from the other locations during the week. Just before we go, guys, I want to point out something I did on the Open Hammer Ranch project podcast the other day when I was talking to Diamond over there. I just want to point this out to you guys, because we're looking at facts now, with regards to what our jet streams are doing. It doesn't matter what day I seem to go on to Null School, I can point out, dislocation of the polar jet stream, and mixing and merging with the subtropical jet stream over the northern hemisphere and over the southern hemisphere. But one thing I want to just point out once more, because I think it's really important, I did point out on the Open Amaranth project, you can go over there and see that live podcast that we did if you want, but I'll just point that out before I leave here, because we've got a different picture over the southern hemisphere compared to the northern hemisphere, and really we're about equilibrium with regards to our position. I know some people call it the tilt, but really we don't tilt. We're not tilting to and from when we're going around the sun. It's just the position of our planet in its natural tilt around its orbit of the sun that gives us the seasons. But we're about equilibrium now, so there shouldn't be too much difference between what's taking place over the southern hemisphere compared to the northern hemisphere. Yet there is, and I propose a bit of a theory to that. So let's have a look on null school before I end this video. Just this important point that I want to make before I leave. So very quickly, guys, this is absolute fact. You can see over the southern hemisphere, and you will see over the northern hemisphere as well if you spin this globe round, and we'll do it, why not? Just around the equatorial region, what we're looking for is fragmentation from subtropical jet streams, and intertwining with the polar jet streams. Here is a fantastic classic. Look what's taking place. First of all, on the southern hemisphere, we've got the subtropical region of the northern hemisphere coming straight across the equatorial region into the subtropical region over the southern hemisphere, mixing with what must be a 4 to probably 5,000 mile wide jet stream. Unprecedented size jet stream, guys. We don't know what the implications of what this is going to cause, but there's a lot of water precipitation in that jet stream which could be dumped at any given moment. Guys, also, more importantly, it's not just the fact that we have this happening both over the northern hemisphere and over the southern hemisphere, and this is evidence of this taking place, but just have a look at this. When we compare the conditions over the Arctic Circle and the northern hemisphere in general over our planet to that of what's going on the Antarctic or southern hemisphere of our planet, it obviously speaks for itself. Look at what is taking place, and let that sink in for a little bit, because this is fact. I've come up with a theory as to why the southern hemisphere looks like it does, as opposed to it being equal at the moment. Like I said, with our transition around the sun at the moment, we're about equilibrium. So the northern hemisphere should be receiving around about what the southern hemisphere is in daylight in any case. But something clearly else is taking place over our southern hemisphere, and what I presume might be the case might well be what is baffling scientists right now with what's taking place with regards to the ozone hole over the Antarctic right now. And that is that we know full well that there's a lot of aerosols that are making up the ozone hole and creating the ozone hole, yet the ozone hole over the last 5 years has been reducing in size when it should be getting bigger in size. That is what's been confusing scientists, and I don't think that they have put two and two together. There is another thing that is inbound on our planet as a result of the weakened magnetosphere, which is our primary protection from cosmic radiation. We also have another weakened secondary protective shield, which is the heliosphere, and due to the low solar output over the last 33 years, it's allowing more cosmic radiation in, and it couldn't be any worse, guys, because we have got a weakened magnetosphere on the planet. In turn, more cosmic radiation is flying through our atmosphere, and I believe it's attaching to those, because now we've found out that this is the case. Cosmic radiation does attach to aerosols, which are small particles. In turn, the more cosmic radiation that attaches to it, it forms a bigger particle, and then we have a particle which is capable of precipitation or causing condensation on. And I just believe that is why, first of all, over our Antarctic region of this planet, we've got a shrinkage of the ozone hole, and you know, those ozones, or those aerosols that make up the ozone hole, are being transported out via the jet streams that we can see right now. And you know, the reason why there's more precipitation in those jet streams, and that's what's making them go so big and so wide, and you know, the peaks and the troughs are snapping at some points and dislocating. They're moving up to the, you know, the subtropical regions from the polar jet stream. You know, the reason why is because we've got more cosmic radiation inbound, and the reason why the southern hemisphere is affected more than the northern hemisphere is because we don't have such a problem with ozone holes like we do over the Antarctic region. And you know, I know it's theoretical, guys. I'm just putting it out there. I'm just saying, well, you know, one thing's there, and we know that one thing, you know, the cosmic radiation is attracted to these aerosols. So why shouldn't it, you know, be the case that, you know, our jet streams have enlarged over the Antarctic region as a direct result of those two things coming together? It makes perfect scientific sense to assume that in any case. So that's what I wanted to share with you. But you know, it is shocking what is taking place on our planet right now, and it can only be more disastrous for certain members of us that share this planet. Guys, there's a link down there. I'm hoping that we can do a little bit more in terms of support for this channel and research. It's unique, it's bespoke. We've got prototypes built and out in the field. You know, I'm just hoping that, you know, we can get a little bit more support and we can continue doing what we do, and that is providing you, you know, first class information regularly on this anomaly that's taking place, on this rarest anomaly that's taking place in mankind's history. So the links are down there. You know, there is a PayPal link. If Patreon's not for you, it's entirely up to you, guys. But you know, we need to have a little bit more support than what we've got right now. You can't have 24,000 people stand by whilst less than 200 people, you know, do something about supporting. We need to increase the numbers. That's in the you know, the short matter of it. So I'm going to say what I usually do, guys. Look out for, you know, an upcoming update throughout the week. You know, when we get some more data from one of the other locations around the world, and of course, you know, keep your eye on the jet streams right now. And I'll say what I usually do. Have a great week. Bye for now.